Okay, class, Assalamu alaikum. We are going towards the end of the biostatistics, and this is the second last lecture in which we will be discussing hypothesis testing. As you all know, that whenever the researcher plans a research, he always makes a hypothesis, and then after conduction of research, whenever he concludes, he accepts or rejects his hypothesis. In today's lecture, we will be discussing what is hypothesis, what are different types of hypothesis, and how the hypothesis is checked when we want to check the sample difference in reference to the population, or when do we check the hypothesis when we are comparing the two sample variations, and how do we check the hypothesis when we are considering the causation and association? What are confidence limits and what are margins of error? So, going towards the hypothesis formation, this is the basically the assumption which a researcher makes, and there are two types of hypothesis: null hypothesis and alternate hypothesis. Null hypothesis says that there is no difference between the two, and the alternate hypothesis says that there is a difference between the two. Let's assume that from a population, a sample is drawn, and now you want to compare the population mean with the sample mean. It means your null hypothesis is that there is no difference in the sample mean and the population mean. But the alternate hypothesis will say that there is a difference between sample mean and the population mean. And whenever you are comparing a population mean with the sample mean, you will calculate the standard error of mean, and you will calculate the confidence limits. And on the basis of those confidence limits, you will accept or reject your null hypothesis. Let me emphasize again the basic empirical thing for which a researcher works is that he wants to accept or reject the null hypothesis. If he accepts the null hypothesis, alternate hypothesis is itself rejected. And if he rejects the null hypothesis, automatically the alternate hypothesis is accepted. Again, I will give you another example. For example, if a researcher takes two samples from the same population and he wants to compare the means of two samples, now he will test his hypothesis by comparing the standard error of difference between two means. If the researcher is dealing with categorical data or qualitative data, then and he wants to compare the proportion in the sample with the proportion of the population, he will calculate the standard error of proportion. And if he takes two samples from the same population and he wants to compare the two proportions, for example, he says that he takes one sample of small children in a community and he wants to see that what is the prevalence of tuberculosis, and then he takes another sample of older population and wants to assess that what is the proportion of the population which is affected by tuberculosis in the older age group. So the null hypothesis will be that there is no difference in the prevalence of both the age groups of the same community when we talk about the prevalence of tuberculosis. And the alternate hypothesis will be no, one of these population has a higher prevalence and the other has a lower prevalence. So what does the researcher will do? The researcher will now calculate the standard error of standard error of difference between two proportions, and by calculating the confidence limits, he will accept or reject the null hypothesis. This makes the base of all the research methodology, epidemiology, and biostatistics. The life of researcher, epidemiologist, and the biostatistician revolves around the null hypothesis, which is of major significance in their lives. So, what happens that if the null hypothesis is accepted on the basis of the results which are actually concluded from the research, and the researcher accepts that the null hypothesis is true, it means the assumption is correct. Fine. But if the research rejects the null hypothesis, but the researcher makes thinks that the null hypothesis is true. He is making type 1 error. It means he has observed a difference when the difference was not present. So this is known as type 1 error. It means now the researcher is saying that I am rejecting the null hypothesis on the basis of my observations and I am accepting the alternate hypothesis. But in true sense, the null hypothesis is true. So in that case, he is committing type 1 error. If the researcher accepts the null hypothesis, when the null hypothesis is actually false, he is committing type 2 error. So he has failed to observe the difference when one exists. It means he is saying that I am accepting the null hypothesis, that there is no difference between the two, but actually there is difference. So he is committing type 2 error, which is known as type 2 error is known as beta error. Fine. And if he rejects the null hypothesis and null hypothesis is wrong, it means he is making correct decision. So alpha error and beta error, type 1 and type 2 errors are those errors which make a concern of the researcher. And the researcher does not want to commit the type 2 error, which is of much more significance as compared to type 1 error. So this is again to show you how the researcher accepts or rejects the null hypothesis, and on the basis of his observations and on the basis of the truth which is present, he is committing type 1 error and type 2 errors. So type 1 error is the alpha error. The null hypothesis is rejected when it is true, and type 2 error is the beta error. The null hypothesis is not rejected when it is false. Researchers think that committing a beta error is much worse than committing a uh, alpha error. So a researcher does not want that he should commit beta error ever. So let's take an example that for example, the population has a mean body temperature of 98.6 degree Fahrenheit. Fine. And if we take a sample from the population, which is, for example, we have taken a sample of 80 adults and we have calculated their temperature, and the temperature has turned to be 98.4 degrees. So what will be your null hypothesis? The null hypothesis will be that there is no difference in the temperature of the sample when we compare it with the temperature of the population. But the alternate hypothesis will say that there is a difference between the two. So how will we go towards the testing of our hypothesis is that we will state null hypothesis, and null hypothesis is always stated as H naught. H naught will say that there is no difference between the population temperature and the sample temperature, and they are equal to 98.6 degrees. And the alternate hypothesis is always denoted by HA, and it will say that there is a difference and the sample temperature is less than the mean sample temperature is less than the temperature of the population. So, how will we test our hypothesis? Number one, we can calculate the standard error of mean. What we will do, we will calculate the standard error of mean by calculating number one, the standard deviation of the sample, and by calculating the mean of the sample, and the standard deviation divided by under root n will give us the standard error. So after calculating the standard error of the mean, we will calculate the confidence limit for 95% interval. So we will calculate the mean plus minus 2 into standard error to calculate the confidence limits. So the population mean plus minus, if we will plus it, it will give us the upper confidence limit, and if we will minus the standard error from the mean, it will give us the lower confidence limit. So by calculating the confidence limits, we will have a range that this temperature of the sample ranges from this point to this point. And if the population mean comes in that range, it means the we will accept the null hypothesis that there is no difference between the two. But if the population mean is away from that sample and it is not lying between the lower confidence limit and the upper confidence limit, we will reject the null hypothesis. And if we will reject the null hypothesis, we will accept the alternate hypothesis. So this is the method one. Fine. And you have done it in our last lecture. What is the second method? The second method is that we calculate p-values to make the decision. And what is p-value? P-value is defined as this is the value which tells us that how likely is that the observed value is lying in the extreme of the sample if the null hypothesis were true. It means that the null hypothesis is true, there is no difference between the two, and the p-value tells us that how far it lies from from the mean. It is in the extreme portion of the sample. Another example can be that p-value depicts the probability of committing alpha error. So the p-value is also known as probability. It is a number between 0 and 1. 0 means no association and 1 means association. There is an association. How the p-values are calculated actually, if the p-value is smaller, it is less than 0.05, then we will reject the null hypothesis and we will accept the alternate hypothesis. As we move farther from 0.05 or we go away from 0.05 in the higher direction, we reject the alternate hypothesis and we accept the null hypothesis. Is that clear? I'm repeating, the p-values are calculated on the basis of accepting or rejecting the null hypothesis. P-values tell us that how extremely the values are present in the normal distribution curve. Tells us about probability of committing error by the researcher. If the p-value is less than 0.05, it means the null hypothesis is rejected and alternate is accepted. And if the p-value is higher than 0.05, the null hypothesis is accepted and the alternate is rejected. Fine. So let me give you an example how this p-value is fixed. When we talk about the confidence interval of plus minus 1 standard deviation, we talk that about the 68.3% of the coverage of the population. We are confident that 68% of the population has been covered between plus 1 and minus 1 standard deviation. If we talk about plus 2 and minus 2 standard deviation, we say that 95.4% or 95% of the population has been covered by the researcher. And if we talk about plus 3 and minus 3, we talk about 99% of the population has been covered. So what do the researchers say? That researcher says that we are 95% confident that our values lie between plus 2 and minus 2 standard deviation. Whenever we talk about this value, we say that 95% of the area is covered between plus 2 and minus 2 standard deviation. So the researcher wants to be confident about 95%. He sets his limit to be 95% confident. If the values lie farther away from the 95% confidence intervals, it means significant difference is present. Fine. Let me give you another example. If we are talking about plus minus 2 standard deviation of a normal distribution curve, it means we are talking about 95% confidence interval. If we are talking about 95% confidence interval, the margin of error will be 5%. 100 minus 95 means 5% margin of error, and 95% we are confident that all the values are lying between plus minus 2 standard deviation of the mean. If I am talking about 5%, I can write this value as 5 over 100. And if I can write this value as 5 over 100, I can also write it as 0.05. So this value gives me a significant value. If the value is lesser than 0.05, it means the values are lying outside the 95% confidence intervals. It means significant difference is already present there. We have to reject the null hypothesis and we have to accept the alternate hypothesis. Fine. And if the values are more than 0.05, it means the values lie between the 95% confidence interval. The margin of error is not 5%. We can accept null hypothesis and we can reject the null hypothesis. This should be very, very clear in your mind. Okay, moving forward. If we talk about plus minus 3 standard deviation, it means our confidence interval is about of 99%. It means the researcher is confident that 99% of the population lies between plus minus 3 standard deviation in a normal distribution curve. And if we are 99% confident, the margin of error will be 1%. 100 minus 99 is equal to 1. And so the margin of error will be 1%. At this point, the researcher can write it as 1 over 100. And if he wants to write it in this form, he can write it at 0.01. So some of the researchers plan that they will fix the p-value at 0.01 to accept or reject the null hypothesis because they want to be 99% confident that their observations are not by chance and there is a significant difference present between the two variables of interest. Normally, the researchers keep a value of 95% confidence and p-value of 0.05. But some researchers who want to do valid work, who want more authenticity in their work, and who want to be more precise and accurate, they deal with plus minus 3 standard deviation. They deal with 99% confidence interval and they fix their p-value at 0.01. They say that if the value will be less than 0.01, then we will accept the alternate hypothesis and we will reject the null hypothesis. But for the undergraduate levels and for the normal researchers, we say that we will deal with plus minus 2 standard deviation. We will be dealing with 95% confidence interval. We will be keeping our margin of error at 0.05. Clear? So how do we calculate these p-values? These p-values are calculated by a large number of tests of significance. There are different softwares which calculate the p-values whenever you order them about the different tests of significance. This is your decision that which test of significance will be applied at which research, in which research. So the most important thing is that the researcher has to keep in mind that what is the outcome variable, whether it is a categorical data or whether it is a numerical data. If it is a categorical data, nominal data or ordinal data, we apply chi-square test of significance. If the value in any of the cell is less than 5, we apply Fisher exact test for the categorical data. If we are dealing with numerical data, we have to think that whether we are dealing with two groups or we are dealing with more than two groups. If we are dealing with two groups, we have to decide that what is the sample size. If the sample size is less than 30, we will apply t-test. And if the sample size is more than 30, we will apply z-test. If we have decided that we are applying t-test, we have to think that whether we are dealing with comparison of two samples, then we will be dealing with independent t-test. And if we are dealing with a paired test of a single group, then we will be doing paired t-test. And if we are dealing with more than two groups, we will be applying ANOVA. Let me give you an example. For example, if a patient, if a researcher goes in a community and he wants to find out two things. Number one, he wants to find out what is the prevalence of anemia. And number two, he wants to find out what is the hemoglobin concentration in that population. So for presence of anemia, he will be doing categorical testing. He will be dealing with categorical data. And if he is dealing with the mean hemoglobin levels, then he is dealing with the numerical data. Okay, let's go towards the categorical data. If he wants to see that is there any difference between the anemia status of male and female population, he will be applying chi-square test of significance. If in tabulation any of the cell has less than value of 5, the chi-square test of significance will not be applied and it will automatically change into Fisher-Exact test when you will be using SPSS, which is Statistical Package of Social Sciences, which is a statistical package which helps us to apply tests of significance, and it helps the researcher to generate the results, and it helps the researcher to find the p-values. Okay, if we are dealing with the hemoglobin levels and we want to see that is there any difference between the hemoglobin levels of male population and female population, it means there are two groups. So now if the sample size is more than 30, we will be applying z-test, and if the sample size is less than 30, we will be applying t-test. Okay, so now if we want to compare the two groups, we will be applying independent t-test. And if we want to see that if a single group of pregnant females with anemia are given oral iron supplementation, and after 6 months the same group has a certain hemoglobin level, and we will be comparing the levels of hemoglobin pre and post intervention, then we will be applying paired t-test because now we are doing paired observation. Okay, if the groups are more than two, in this case in which we are dealing with the numerical data, we will be applying ANOVA. All these tests of significance will be ordered in statistical package of social sciences, and you will get the p-values by cross tabulations between the two independent and dependent variable. The p-values will be given, and how will we interpret this p-values? For example, this is the statistical software. The results have been generated, and the p-value is 0.0026. So what will you say that if the p-value is less than 0.05, it means it is significant difference. So if there is significant difference, then we will reject the null hypothesis and we will accept the alternate hypothesis. And for the same example which I have quoted, we will say that the sample which is taken from the population has a temperature which is statistically significantly different from the population mean temperature. So the alternate hypothesis is accepted and null hypothesis is rejected. This is how we calculate p-values and how we interpret p-values. Now my decision will be reject the null hypothesis, accept the alternate hypothesis. So my conclusion is that the average body temperature of my sample is lower than 98.6 degrees, and it is not truly reflecting the population mean temperature in degrees. So if you have any questions, you can contact me. Tests of significance are important. Interpretation of p-values are important. And where do you apply these tests? Null hypothesis, alternate hypothesis, and the errors which are committed by the researcher are important from examination point of view. Thank you so much.